Now, we were going to discuss um, the language that digital systems use. And there are different types of number system. The computer system, no, um, uses digital signals, no, and there is a computer sa language sa computers or sa there is a digital space. There's no number system that is base 1. Ang pinaka mubuo gyud is base 2. Kaya ang digital, ang pinaka least gyud niya is either two values, 0 or 1, on or off. And sa number system, we will be more dealing about the format of these numbers. We will be particularly cautious about kaning radix, as it defines what number system it belongs under the digital, and syempre ano ang kanyang base. So the highest symbol of any number system is equal to radix minus 1. So for example, if your radix is 9, so your number only plays from 0 to 8. If the number system is only 8, then 8 minus 1 is 7. So the highest number in your number system is 7. Yan. The highest symbol plus 1 equals 0 with carry 1. Yan. Always yun siya. Okay. So that's the common nature, no? So nature ito ng digital system. So yan. So now, these are the common number system. Natay ginatawag nga decimal system, binary system, and napod tayo octal system. Kung maingon ka og kaning decimal system, it said to be so decimal system is said to be using base 10, and because it uses 10 digits, the coefficient are multiplied by the powers of 10. Okay, the highest digit is 9. Why? Because our this is base 10 and radix and so since this is base 10, meaning it uses numbers from 0 to 9, no? Why? Because apil man sa 0, no? So a radix is 10 minus 1, so equivalent to 9. Therefore 9 is the highest number. Binary system, there are only two possible values, that is 0 or 1, and this is mostly used in our digital system. Octal has a radix of 8 and the highest digit is 7. Hexadecimal uses 15 characters, but after leaving 0 to 9, we will start using letters from A to F. So ang A na to na ang 10, ang F na to ba na yung 15. Kaya ang highest digit na to is 15. Kasagaran kaning hexadecimal is used for registers, kanang mag-store na kag memory. Another important concept nga ato ang ma-encounter dinhi sa number system is the positional notation. This is most especially used when we are going to convert any base number to the decimal to its decimal equivalent. Now, ang positional notation is actually the value of the number multiplied by each of the digit by a weight then and summing it in. So the weight of the digit is basically the power of the base, and it's determined by its position. So for example, we have a base of 10 in the first example, and then the power is actually the weight based on the position. For example, for our 872 no na problem, so 872.64, so the first number from the left is actually the most significant bit. So the most significant bit receives the highest exponent. So and then coming from the decimal point, going to the left, kasi papunta tayo ng most significant bit. So dito magsa-start yung exponent natin na 0, and then 1, and then itong 8 has an exponent of 2 that is raised to the base. And then going to the right naman, we have 6. Dito na magsisimula yung negative 1 and then negative 2. So to work this out, we have here 8, no? As you can see, the exponent that we use here is 2. So ang ginamit natin is base 10. So the same case with the 7 here, and then also the 2 here, and then pati na yung 6 at saka 4. So ang gagawin is we need just to sum it. And then after mag-sum, so gamitin natin ang calculator natin, we come off with the value of with the value na equivalent to this, no? Still the equivalent is still 872.64. But later on, if our base will change, no? For example, ito, and then we want to convert this, no, binary. This is a binary number system. Ko-convert natin siya sa decimal. Pag ganun yung mangyayari, so base, tapos identify natin kung anong exponent based sa weight niya, no? You need to always take note that yung pinaka most significant bit, siya yung pinaka mataas na exponent. So in this case, yung position niya is nasa 3, ito 2, 1, and then may times din, no? Ayan, and then 0, and then negative 1. So may times din na 0. So kung 0 ito, so hindi siya kasali, but still, no, nilagay pa rin natin dito just to see na we always consider them, but yung value nila or weight nila is equivalent to 0. So we come up with 11.5 base of 10, which is originally coming from 1011.1, which is in a binary number system. So here we are in our number base conversion, and we have here decimal to any base r. Pag decimal to any base r, for the integer part, ang gagawin lang is i-divide siya sa kung ano ang base na given. And then use the remainder to form the required base number in an up-ordered manner. And as for the fractional part, multiply lang natin yung decimal like it is depicted here at our example here. Yung gagawin lang is i-extract lang i-minus lang natin yung whole numbers natin dito. So we will just be dealing with our decimal. And then gagawin lang is that multiply lang natin kung ano yung base. In this case, our base here is 2, no? Kasi doon natin gagawin yung conversion natin. Kasi yung conversion na gagawin natin dito sa example is decimal to binary. So pag papunta sa isang number system, so yun na yung gagamitin natin na i-multiply natin dito. So we come up with 1.375. Yung 1 niya na whole number, yun yung ilalagay natin dito sa gilid as our coefficient. And then tatanggalin natin, since tinanggal natin yan, so multiply na naman natin ng 2, we come up with 0.75. So 0 yung kanyang whole number, so 0 din yung ilalagay natin sa kabila. And then 0.75 times 2, we have 1 na already, so we put here 1. And then yung 0.5, yun na naman yung magko-continue multiplied by 2, and so on and so forth. And you will just stop based on kung ano yung instruction na ibibigay, kung ilang decimal digits lang ang i-allow. So for example, we have here 3 example, and let's solve this. So for letter A, we have 53.1234 base of 10. So this is decimal in nature, and then i-convert natin sa decimal. So for the integer part, which is yung 53, yung gagawin natin is i-divide natin siya sa number system na i-convert natin. So 2 divided by 53. So meron tayong remainder na 1, but meron tayong answer na 26. Why? When you use your calculator, yung lalabas kasi is pag 53 divided by 26. Ano ha? 53 divided by 26 is 2.038. Sorry. Mali pala. 53 divided by 2, we have 26.5. So, yung 26.5 na yon, yung 26.5 na yon na result, yung 26 malalagay dito. And then yung 0.5, which is ito yung remainder, 'di ba? Yung 0.5, so minus natin sa calculator yung 26 para maging 0.5. And then yung 0.5, i-multiply natin sa base number, which is 2. So meron siyang ibibigay na 1. Okay? And then yeah, no? So ang palatandaan lang natin dito sa binary, magko-convert tayo decimal to binary. Pag ang decimal point is 0.5, automatic 1 yan. Pag walang decimal, no? For example, divisible siya by 2, no? More likely. So yan, equivalent to 0 kaagad yan kasi walang remainder. Yan, sige. So, I think you know already what will happen here. So, 26 divided by 2 is, obviously, remainder natin dyan is 0, no? So, since magde-divide pa rin tayo, so that's equivalent to 13. So, ito add to, so 1, automatic. So, pero 13 divided by 2 is 6, no? 6 something. And we know, 6 divided by 2 is 0 yan kasi divisible ng 2 eh, di ba? Tapos, we have 3 na naman as divided by, as the result of the division of 6 and 2. And then, we have 1 again. And then, 1 divided by 2, that's 1 because 0.5 yung labas niya. Pero yung integer, pag ang integer na natin ay naging 0 na, so, yan, doon na tayo magsa-stop. And then, yung arrangement nito is that the last remainder that you've solved is actually the most significant bit. And then, papunta ng taas, ito yung LSB natin. Okay? And then, how about the decimal part? So, we already demonstrated how it is done. So, yung gagawin natin dito is diretso na. So times 2, that's 0. So, pag multiply na naman ng 2, we have 0.2468. So, still, our integer part is 0. Ito pa rin is 0, no? And then hanggang sa meron na tayong ano. So ang result ng 0.9872 times 2 is actually equivalent to 1.9744.44, no? Yung decimal na naman yun, yung 0.9744, multiply na naman natin ng 2 and still we got an integer of 1. Okay? I-try nyo sa calculator nyo. And then, after that, still, we come up with 1. So, hanggang 6 decimal places lang tayo. So, yan. So, baliktad naman dito, yung pinaka-first na decimal result, no? Integer result is, yun yung ilalagay natin dito. So, actually, this is not an equivalent point, but this is an arrow dapat, no? Because yung ilalagay natin dito are integer. Yung integers, yung result na, yung integer result lang. And sa dito sa subject natin, we will just use 6 decimal places as our final answer. So, ito na yung answer natin. So, combine natin yung value natin dito at saka yung value natin dito. We come up with this answer. Ganyan lang, no? Very simple. Let's do some example. So for example, ang decimal imo na to siyang octal. So the same ra gyapon ang process, no? 623 divide na to og 8. Unsa ang remainder niya ana? So unsay result sa ani? 628 623 I mean 623 divide na to og 8. So atong result is 77. Pero what we are targeting is itong 0.75, no? So kaning 0.75 multiply lang nato sa atong base, which is gigamit atong divide kaniya, which is 8. So we come up with the number 7, no? So remainder nato is 7. So katong ato ang na-divide kaganiha, which results to an integer of 77, mao na pud tong ato ang i-divide, no? So 8, so pila man ni 9.62625. So kabalo na ta na 9, pero kaning 625 minus 9 na lang nato sa inyong calculator, multiply na to og 8. So we come up with 5, no? Is when you are listening to this slide, maayog inyohang ikuan, no? Inyoha pong sundon ang inyohang calculator aron nga masabtan po ninyo ang process. And then mao po na mahitabo, no? So 9 tapos si 9 divide na po nato kang 8. Na po tay decimal point nga 0.125. So kanang 0.125 na pod mo na po na i-multiply sa base, which is mo resulta og 1. Then 1 naman ni siya daan. So ato na lang i-continue. And as long as ang mahitabo ang imong integer nga makuha within the process is mag-0 na gani, dira na ka mag-stop. So still, as I would like to remind you everyone, emphasize also that ang pinaka last nga remainder nga makuha mo na ang MSB, and then ang pinakauna may imong LSB. Okay? So sa decimal point, sa decimal area, no, kaning 0.021, pareha ra gyapon. So mao ra gyapon ang mahitabo. So kung i-multiply man gud nimo si 0.021 kang 8, ang integer niya is 0. So kaon nimo tong decimal part niya, which is ang decimal part is 0.168. Mao na pud tay multiply nimo kang 8. So which is nag-result siya og integer nga equivalent to 1. And then kaon na pud nimo ang iyang decimal, which is 0.344. Mao na pud nimo multiply og 8. And then hantod nga maabot ta og 6 decimal places. And ang pinakauna nga atong nakuha is our most significant bit, and pinaka last is LSB. So still up to 6 decimal places ta mga higala. So mao na ato ang answer na dayon. And always mamali ang inyong answer pag mali ang inyong base or nalimtan ninyo og butang og base. That is why very important nga dili ninyo kalimtan ng base. Ang pangutana, if kaning 10 pwede ra ba ni siya wala? Yes, pwede ra kayo wala. It is understood nga pag walay base ang isa ka number, that is implemented in decimal form. Okay, next, what if kung hexa? Wala na, expert na kayo ta. Kaon lang nato ang integer part nato nga 2017, and then mo na ato ang himuon. So ang remainder 1. So then ang boni ang result sa atong division kaganiha, ang integer result sa ato ang pag divide sa 2017 og 16, 126. Yeah, remainder na to 14, 7. So kana, sorry, nasubraan ang ako ang pag next. So kabalutam nga pag after sa 0 to 9, ang equivalent sa 10 is A. Ang equivalent sa 11 is B. Ang equivalent sa 12 is C. Ang equivalent sa 13 is D, and then equivalent sa 14 is E, and then equivalent sa 15 is F, no? So 10, 11, 12, 13, 14, and then 15. So that is why ang atong 14 adopts the equivalent hexadecimal nga equivalent niya, which is letter E. So when it comes to our the same thing, no, MSB to LSB. So for our decimal part, which is 0.21, so dapat na rin siya 1 day ni dire, no. So mao ra gyapon ang process. So kaon lang nato ang integer part natay 5 nya, kaon na po nato ang decimal part sa 5. So mao na po nato multiply sa 16, And then, kuha na, extract na to ang integer part, which is 1. And then, kuha na po na to ang decimal part. I-multiply sa 16. We have 14. So, it really takes a practice, guys, no? So, even, no, kaning pag-identify na to, 11, that's B in hexadecimal. No po na nga to ang hinumduman. So, I think, mara ni ang kuha niya. So, MSB 2, LSB, and our answer is 7E1.051EB8. Okay. Muna siya ang ato ang answer, no? So, very simple lang. So, also take note that our radix here is ato ang radix din here is equivalent to H or 16. So, pwede tamo implement og H, pwede po taog 16. Okay, what if baliktaron nato? Gikan sa any base, no? This is any base. Any base to decimal. Kung any base to decimal, di na magamit tong positional notation. No, so muna na siya katong illustrate na to. So example ta diretso, no, sa letter. So in the given, we have A, B, E, 5. So first, kailangan natin ma-identify ano yung mga weights ng every digit natin dito or character. So, coming from the decimal point, papunta tayo ng left. We have here 0 starting from the least significant, no? Then ito 1. And then coming from the decimal point, papuntang right, we have mag-start yung negative natin. So, negative 1, negative 2, and then negative 3. So, yun din yung gagawin natin. So, for A, since A is equivalent to 10, so 10 times the base, which is 16, erase natin sa kung ano yung kanyang exponent, which is 1. Sum natin, or add natin sa B, which is equivalent to 11, and with the exponent of 0, with the base of 16. And then, E, since this is equivalent to 14, diba? So, yun din yung kanyang kinalabasan with the corresponding weight of the exponent. And another one, E. And lastly, 5. Yan. So, kung gagamitin natin yung ating calculator para dito sa ating, sa ating calculation, so yung mangyayari lang is that we will first clear, no, our, clear ko muna itong, itong aking calculator. And then ang gagawin ko is that I will designate A A, no, as equivalent to 16 mamaya. So lalagyan ko lang para isahan lang yung pag-input. So kaya yung arrangement ko dito is 10A raised to 1, and then 10 raised to 0, then 14A raised to negative 1, no? And then plus natin dito sa 14, then alpha A, then raised to negative 2, yan. Tapos add natin sa 5A raised to negative 3 ito. Yan, so kailangan natin ng value, no? Kailangan nating pindutin yung calc, and then set tayo ng value which is 16. Yan, equate lang natin. After nyan, ito na makukuha natin. So after that, the answer is this. Yan, yung answer natin. So, very easy lang, no, gamit ang ating calculator. So how about this example? So we have here a 1007.143. So next, gagawin natin is to identify the weights. So coming from the decimal point papuntang left, we have here 0, 1, 2, and 3 exponent. Then nandito negative 1, negative 2, and negative 3. So yung gagawin na lang natin, ano na lang. So 1, multiply natin sa base, and then the corresponding exponent, which is 3. and then ito din yung exponent natin, and then we have here 0, no? That's our equivalent. Then ito rin 0, then ito 7, this is 1, 4, pero nasa negative 2 na siya, and then 3, negative 3. Yan. So sum lang natin, i-add lang natin sila. Then pwede nating gawin yung ginawa natin sa calculator as what I was able to demonstrate, and then equate natin. Ito na yung magiging answer. The same thing with this. So coming from so this is binary to decimal. So still lilista natin sila 1 0 1 0 1 1 0 1.101. Yan. So simple lang, no? Same lang pa rin. So identify natin muna yung mga exponents natin coming from the right, coming from the decimal point papuntang left, and then ito din papuntang right. So ito na yung mga equivalent nila. And then sum natin. Yan. Then please repeat what I did on the calculator. Yun lang yung proseso. Pwede natin gawin si A dito, which is equivalent to 2 sa calculator, para hindi masyadong hassle, no? At saka hindi na maraming inputs yung ating pagdadaanan. So we have the answer of 159.1933. Yan yung ating equivalent dito. Okay, so now, what if kung any base to any base? So pag any base to any base mo naagyod sa middle nila si base 10, always mo agyod ka og base 10. Pananglitan gikan ka og octa mo ni mong binary, no? Kana tangan mo ni mong binary. So ang buhaton gyud na moagi gyud na siya in between og base 10. Okay? Ana lang but pasabot ani ni. So pananglitan binary to octal. So kung binary to octal gani ang atong kuan, dali ra ni kaayo ngano man kay grupo ra man nimo ang imuhang mga value gikan sa least significant bit padulong sa most significant bit by 3, and then convert siya sa iyang equivalent. Pananglitan natay example, no, mo niya to ang decimal, ato ang binary, ato ang given binary is 10110111 yan natay point diri mo niya to ang given. So atong gihimo ang sara gikan dinhi mo grupo ta og tinag grupo ta og tinagkuan tulo, no? So natay tinagtulo din nga given, no? So natay kani gikan na isa naputay sa grupo, report naputay sa grupo, then ay kaduhang grupo. So inana lang ato ang buhaton, no? Pag magkuan mag-solve ta og kanang binary to octal. Yan. So kani siya nani siya equivalent. So kani siya equivalent to 2. Nganong equivalent to 2 man na siya? It's because, di ba, sa ato ang number system we have this, no? For example, this is 3 digit, no? So siyempre yung sugod og 0, 1 ug 2. Kani siya ang 2 raised to 0 is 1. 2 raised to 2 at 2 raised to 1 is 2. 2 raised to 2 is 4. So kung forma tag 2 para makay equivalent tag 2, 0 ni siya, 1 and then 0. Man ang 0 1 0. For example, gusto mo forma og kani 1 1 0. Kung 1 1 0 siya, meaning 4 plus 2, 6 plus 1 1 1 0, no? So kung 1 1 0, you have 4 plus 2, that's equivalent to 6, and then 0 man is 1, so that's equivalent to 6. Kaning 1 1 1 kung naa nay kuan dire 1, so 6 plus 1, that's equivalent to obviously 7. Then kung 0 1 1, so 2 plus 1 is 3. Ana. So mo na answer 26. And ayag kalimta ato ang radix din na kay mamali man ka. Okay. So what if kung convert, let's say kaning example, no? I will let you solve this problem, no? Kung pwede sa inyo. So pero kung inani no may tabok, so ato lang i-grupo tagtulo. Yan, tagtulo. So gikan dire imong paggrupo ha. Diri pod padulong din ha. Okay? So this is equivalent to 5, this is equivalent to 5, this is equivalent to 2, this is equivalent to 2. Okay? Punta nga 0 din ha. Okay? So morning answer na to, no? Dahil na kasimple. So what if kung baliktad, octal to binary. So kailangan lang octal to binary. Example ta diretso, no? So natay 7, no? So 7, tapos natay 5, natay 4, natay 6, then natay 2, natay 2 pod. So natay point dila, no? So kani equivalent ni 5 is 101, si 4 kay 100, si 6 is 110, si 2 is 010, 010. Then atong buhaton lang, i-combine lang ni sila. So na siya. Ngana lang guys, no? Dapat niya 0 din sa last. Kinaaman ni siya. So, pwede lang pagwala. Okay? So, ana lang itong buhaton. So, let's proceed. What if kung binary to hexadecimal? Kung kang octal tagtulo, kani siya by 4. So, pananglita natay nani nga example, no? So, kita na to nga gigrupo nato siya. Gikan padulong din ni sa ato ang left, no? Gigrupo nato siya gikaupat. Nya, kani kulangan siya og isa ka digit para maupat. So, pwede ra ni 0 sa pinaka significant bit. Then padulong po ni siya dito. Yan. So, kani siya, this is 1. This is obviously 6. This is equivalent to E or 14. And this is equivalent to C because the equivalent is 12. Okay? So, ang answer natin now, for this problem, if you are listening right now, please submit your answer in the UVE, no, that I will be providing the link. So with this, I'm expecting na pwede niyo na siyang mansiran within the exercise or ma-ready mo ani sunod sa ato ang activity. Okay, so now for our hexadecimal to binary, what we'll gonna do is that each of the hexadecimal character given or digit, kailangan nimo lang siyang i-represent to 4 bits. For example, we have here 8 E dot A2, no? Unsa man ang equivalent ni 8 sa unsa equivalent na binary ni 8 sa hexadecimal? So that's equivalent to 1000. Si E it's equivalent to 14. So 14 in binary, that's 110. Si A is 10. Therefore si A is 1010. Si 2 is 0010. Okay? So what we will gonna do is that combine lang nimo ni sila. So we come up with a binary equivalent. Okay. Now, your turn, no? Please answer this question. And let's check, no, if tama ang inyong answer the moment na inyong i-submit ng inyong answer sa ato ang activity. If you're watching this video. So this is the my basis if you're really watching the video that I uploaded. Okay, so next is hexadecimal to octal or octal to hexadecimal. So when we involve conversion from these units or vice versa, we need to undergo first binary conversion and then converting it to the desired number system, which is in this case is galing sa hex, binary muna, tapos from binary maging octal. The same thing din sa octal, binary muna, tapos hexagonal. So let's take some examples here. So in this example, we will convert 374.34, which is in octal, to hexadecimal. So 374.34. So gagawin muna natin is to convert that every digit to its equivalent binary. So for example, sa 3 we have 011, sa 7 is 111, sa 4 is 100, sa 10 point, tapos sa 3 is 011, and sa 4 is 111. So ang gagawin natin is that we will group this, no, into 4 kasi hexa. So yan, so coming from here, no, sa decimal point natin papuntang left natin, so dyan magsa-start, no, yung ating grouping. And then the same thing din dito sa kabila, galing dito sa decimal point papunta dito sa right. So yan din yung gagawin natin. So yung kulang, fill in lang natin ng 0. So pwede din dito, pero 0 pa rin yun siya, eh. So wala pa rin salbi. So after that, no, after fulfilling or after making everything group, no, based on the equivalent weights, so yung mangyayari sunod is convert na natin kung ano equivalent niya. So for example, ito, this is equivalent to C kasi this is equivalent to 13, and then ito F because this is equivalent to 15. Ito naman is 7, and then ito naman is 0. So yung answer natin is FC.7. Tapos hindi natin kakalimutan ang H. About from hexadecimal to octa. So we have here FAB.34. So then gagawin is co-convert natin ang binary into binary ang every digit. So for example, for F, that's equivalent to 41. Sa A is 1010, si B is 1011, si 3 is 0011, and si 4 is 0100. And so group natin siya, no? And since this is converted to octa, so ang grouping naman niya dito coming from the decimal point papunta po tayo sa left is by 3. So yan, 3, then 3 din, ito 3 din, then ito 3 din. Then coming din dito from decimal point papuntang right side, we have yan, no? So fill in lang natin, pero still 0, so wala pa rin. So after that, so equivalent nila is ito siya 3, this is 5, this is 6, and then this is 7. So this is 1, this is 5, and then this is 0. So ganun lang, no, if you want to convert everything. Ayan, para klaro. Okay, so next, yan, ito yung answer. So next concept is all about complements. So complement is widely used in digital system, especially for simplifying. So I bold and I italize the word simplifying subtraction operation kasi nga in logic circuits or in Boolean algebra, there is no such thing as subtraction. There is ginagawang complementing yung tawag natin dito. But there are two types of complements. First is the radix minus 1 complement, and the second one is the true complement or the R's complement. So how they differ from each other? So let's take for example itong ating radix minus 1 complement. Ang radix minus 1 complement din natin is also known as diminished radix complement or base minus 1 complement. So let's say for example, magsosolve tayo ng tatlong problems dito. So for example, itong kunin daw natin yung 9's complement. So 9's complement because yun na nga, we have our base equivalent to 10. So 10 minus 1, that's equivalent to 9. Kaya 9's complement. So when we involve ourselves with this, so yung gagawin lang natin is that this will be our, so ima-minus lang natin itong number, itong given natin sa puros 9 lahat, no? after natin yan ma-minus, so ito na yung itsura, no? So, kasi ito 9, this is 1. So, yan. Tapos ito naman is 2, ito 3, and ito 4, and then ito na 8. So, yan. So, for example, ito ding isa, decimal. So, itong decimal, every digit niya, minus natin sa 9. So, ito rin yung result niya. Yan. So, 9, 1, 4, 7, 6, and then 9. So, yan yung answer natin pag 9's complement. So, for example, ito, r minus 1 of the following. So, if we have 8, therefore, if ito yung given natin, 124.5, so, ano ang ima-minus natin sa yung magiging subtrahend natin for every of the digit. So r natin is 8, so minus 1 is equivalent to 7. Kaya 7 ito lahat. So perform natin itong mga digit itong mga column natin. So we come up with 653.2. Tapos meron talaga tayong base 8 dito. The same thing with this. So for what if kung hindi not the common radix yung ibibigay. So, for example, ito, 341.23. So, 5 minus 1, obviously, we have 4. So, perform lang natin itong subtraction ang per column natin. So, ito na yung result, 103.21. So, ganyan lang yung technique natin dito. And then, what if kung 1's complement? So, kung 1's complement, so, 2 minus 1, no? So, that's 1. So, 1. Kaya 1 yan. So, ang result, so 00.10. So, yan. So, meron ding isang technique pag binary. So, simply, kung ito yung value natin, so, i-invert lang natin. So, 0, 0, 0, 1, 0. So, yan. So, similar lang sila. Lang yan sila. So, invert lang natin. So, what if kung true's complement or r's complement? So, yung gagawin lang is that we will still perform the radix minus 1 complement pero mag-a-add tayo ng isa. So, as you would notice here, these are the same problems that we perform in the radix minus 1 complement. So, yung gagawin na lang natin is to add 1 where to the least significant digit. In this case, no, ito yung example natin kanina, meron na tayong result. So yung gagawin lang, mag-a-add 1 lang tayo sa least significant digit, which is in case nakalocate siya dito. So this is equivalent to 0 na, no? And then carry 1, so kaya nagkaroon tayo ng 2. Then the rest here is already copied. So this is our answer. Yung 2 naman, no, yung 0.325. So, ito na yung answer natin kanina. I-add lang natin ng 1 sa pinaka-last. So, meron tayong 0. And then, meron tayong plus 1. So, meron tayong 2. Ayan din yung ano natin. No? Hindi na natin kailangan ilagyan ng radix because this is already decimal. So, next, what is the true complement of the following? So, ito yung nakuha natin, na answer natin kanina, no? Meron na tayong answer nito. Itong 653.2. So, gagawin, add na lang tayo ng isa. So, magiging 653.3. Ito din yung gagawin natin sa 2, which is, ito na yung answer na nakuha natin kanina. And then, just add 1 to the least significant bit. And we have that. Okay? So, ito na yung answer natin. So, ganun lang, kasimple, and now, for example, ito. Yung gagawin lang natin, di ba, meron na tayong nakuha kanina, add lang pa rin tayo sa pinakalas. So, yan, naging 0.11. Yan, okay, no? Dali lang masyado ang complement. So, actually, we are already performing subtraction. Okay? Now, we are in the binary arithmetic na. So, in binary arithmetic, we have 4 operations: the addition, subtraction, multiplication, and division. So let's get started with our addition. So in our addition, we have a different setup here. This is different from the algebra that we are used to compute, or arithmetic of decimal numbers that we are used to compute. So in here, if our oggend and our addend is 0, ang sum natin is equivalent to 0, and 0 din yung carry natin. So the result is 0. Pag ang oggend natin is 0 and then addend natin is 1, obviously we have 1. No? This is also the same with oggend is 1 and then addend and 0. We have the same value, the same output, magiging 1 siya. And we have also the same output na magsi-0 yung ating carry. So the result is 1. No? Pero if both of our oggend and addend is 1, so ang mangyayari, magsi-0 ang ating sum. So magkakaroon na tayo ng carry. So ang result niyan is 1, 0. So ganun lang, no, ang ating arithmetic. So for example, ito, we have here the given. So to bring down kaagad 1. This is equivalent to 1. This is equivalent to 1. So 0 and 1 and 1, that's equivalent to 0. And then carry 1. So that's 0 again. Tapos that. So lagay natin yung carry natin. So 0 pa rin yan. And then ito. So this is 1, 0. No? But may additional 1 tayo. So that's equivalent to 3 na. And 3 in decimal, in binary is 1, 1. So, mangyayari, the sum here is 1, and we have carry 1. So, the same pa rin 3. So, 1, and then magki-carry tayo ng 1. So, 1 at saka 1 is 0, and then carry 1. So, we have 1 and 1. So, huwag kakalimutan ang radix natin na 2. So, the same thing here with our next example sa number 2. Sa next example lang, ang problema is that we need to convert the number, no? Yung 534.437 with a base of an octal to binary. So need natin muna ito convert. So kung i-convert natin siya, yung equivalent niya is 1, 0, 1, 0, tatlong 1, and then 0, 0, 0 point. Meron tayong 1, 0, 0, 0. And then, meron tayong 5 1, 1, 2, 3, 4, 5. So, medyo kailangan natin ng malaking space, no? Kasi hindi masyadong decent yung ating yan. So, lagay muna natin sa isang malaking space para makapagsulat tayo. So, this is equivalent to si 5, diba? 101. Si 3 is 011. Si 4 is 100. Dot 100. Then 011. And then 7 is 111. So, dito naman, si 4. So, galing dito, si 4 is 001. Then 7 is 1, 1. And then 1. Then A is 1010, and then 5 is 101. So, add lang natin yan sila. So, bring down kaagad natin ang dalawang 1 dito. We have here 0, then carry 1. We have 1. And then, okay, carry siya sa 0, no? So 0 pa rin pala ito. Tapos, mag-carry tayo ng 1. So, this is 1. And then, carry 1. This is 1, 1. 0, 0, dot 1, 0, 0, 1, 1, 1, 1, 1, 0, 1, 0, 1, 1, and then 1. Then yung equivalent natin. Okay? So, naka-decimal. So, since dalawa yung expected natin yung 1 and 16 and 8. So, yung mangyayari for the so this is group 1. So octal, this is group 1. Then this is group 2. Group 3. Yan. So this is equivalent to 1. this is equivalent to 3, and then this is equivalent to 6. Ito naman, this is equivalent to 1, this is equivalent to 6, and then this is equivalent to 3, and this is octal. So kopyahin lang pod nato ning isa, 1 1 2 0 1 1 2 0 1.001 1 1 0 0 1 1. So nangyari apat, no? Yan. So ito din apat. Yan. So this is equivalent to what? This is equivalent to 9. This is equivalent to 9 pa rin. This is equivalent to 1. Ito, this is equivalent to 3. This is equivalent to 9. And this is equivalent to 8. So this is our hexa. Okay? So that's our answers for this problem. So ito din. Pero pwede ba diretsuhin? Pwede, actually. So, for example, ito 10. So, 10 minus 8, that's equivalent to 2. Then, carry 1. So, ganun ha. So, diba, 5 plus 5 is equivalent to, that's 10. Pero, diba, sa octal, yung max value lang, yung number system niya involves 0, number, 1, 2, 3, 4, 5, 6, hanggang 7 lang. So, kasi ito, nanobra ito. So, minus lang natin sa 8. So, pag 8, equivalent to 2. So, 2. So, pero magkikarry 1 tayo dito. So, 6 plus 4, that's still 10 plus 1, that's 11. So, 11 minus 8, that's 3. So, kaya ang malalagay dito is 3. And then, 3. So, mag-carry 1 na po ta. 10. So, 10. Tapos, 11. So, 3 gapon. So, carry 1 gapon ta. So, kani siya mahimong 11, 12. So, 12 minus sa. So, magiging 4 ito. Carry 1. Magiging ano ito? 10 pa rin. So, 10. Magiging 2 ito. Carry 1. So, magiging ano ito? 7. Tapos, magkakaroon tayo ng ano? 7, 8, no? So, 8 minus 8 is actually equivalent to 0. And then, carry 1 tayo. Ganyan. So, ito yung ating equivalent, no? Sa octal. Pero, still, no? Pag hindi ka masyadong komportable sa ganito, pwede din naman na binary. Convert muna natin ito ng binary. And then, convert natin ng octal. So, pag ganito lang, pag iba yung base natin, for example, ito naka-octal, na ito naka-hexa. So, kailangan na lang natin siyang i-convert each of the given to to a decimal. To binary, I mean. No? Okay? So, that's all. So, next na naman tayo na arithmetic binary operation. Next is itong binary subtraction. So, in 3 ways, it can be performed. First, by direct method, the R's complement or truth complement method, and pwede din yung radix minus 1 na complements method. So, let's get started by understanding first ano yung paano natin i-approach yung every bits. For example, pag minuend natin is 0 and then subtrahend din natin 0, syempre 0 ang difference nila, borrow din natin is 0. Pero for example, minuend natin is 0 and then yung subtrahend natin is 1, so parang ibig sabihin smaller number is subtracted by a bigger number. So pag ganun ang mangyayari, the difference, logically the difference is 1, but we need to borrow another 1. Okay? So, yan. Pero pag ang minuend is mas malaki kaysa sa subtrahend, so the difference is 1, but we don't need to borrow. This is just when minuend is smaller than our subtrahend na mag-borrow ka. Okay? Pero, pag atong minuend and subtrahend is 1, both 1. Syempre, difference is 0, and we don't need to borrow. So, now we're ready to solve each of the problems here. So, natay tulo ka problem din eh. So, let's try first na ito. So, we will first use the direct method. So, sa direct method, so ang gagawin lang natin is simply using the table, no? Applying what we have learned in the table. So, this is equivalent to 1. This is equivalent to 0, 0, and then 0. Okay? So, that's the answer. Pero pag gamitan natin siya ng radix minus 1 method, yung mangyayari ganito. So, yung ating subtrahend will be converted to its ones complement. So, di ba pag ones complement at saka binary, ano yung gagawin natin? I-invert lang natin. So, magiging 0, 1, 1, 1. At pag once na ma-invert na natin or nagamitan natin ng ones complement, yung gagawin natin, i-add natin siya sa ating minuend, which is 1, 0, 0, 1. So, once we've done that, so i-add na natin. So, we have 0, and then we have carried 1 here, and then 1 plus 1 is still 0, and then carry 1. So 1 plus 1 is 0, and then carry 1, and then we have 0, and then take note that we have here what we call an overflow bit. Once nga meron tayong overflow bit, yung gagawin natin, i-add natin siya dito sa least significant bit. While yung gagawin is i-remove natin itong kailangan pala di lang na-remove, pero kailangan na-remove na ito. Yan yung answer. Okay? So, what if kung gagamitin natin ang truth complement or Irish complement? Yung mangyayari, perform muna natin yung ones complement, and then add tayo ng isa. So, mangyayari is magiging 0 to, carry 1, so 0, carry 1, 0, and then it carry 1, maging 1, 0, 0. Ito siya ngayon ay 2's complement na. So, i-add natin dyan sa subtrahend natin. So, mangyari, this is 1, 0, 0, and then 0, 1. No? So, meron tayong tinatawag dito na overflow bit. So, mangyari dito sa overflow bit natin, matatanggal ito. Yan. So, yan na yung magiging natin. Okay? So, another example, ganito. So, by direct method, yung anong napansin nyo sa ating given. So, si minuend is lesser than the subtrahend. So, medyo complicated, no? So mangyayari pag direct method, syempre magbabaro tayo dito kasi 0 lahat yung natin minuend eh. So, mangyayari ito magiging 0. So, ito magiging 1, 0. Ito, hiram na naman tayo. So, magiging 1 na lang ito. Ito magiging 1, 0. Ito, hiramin na naman natin. So, magiging 1 na lang siya. Ito magiging 1. Okay, so yan, magiging 1. 1, 0 ito, no? Sorry. So, magiging 1, 0 minus 1 is 1. 1 minus 0 is 1. 1 minus 0 is 1. And then, since this is 0, so, kailangan na naman natin magbaro sa kabila. So, this is equivalent to 1, 0 minus 1. So, 0. So, hanggang infinite na ito, no? So, yan. So, yan. Meaning nito, itong nag-overflow dito, meaning super negative. Kaya ang given na to, kung sa kuan siya, this is 8 and this is 9 in decimal, no? So, magiging negative 1 talaga ito. So, this is the negative 1 represents here. Okay? So, let's examine na naman kung yung by radix minus 1 method. So, mangyari, still gagawin natin is ito yung magiging first complement. So, invert muna natin. After that, i-add natin sa ating minuend. So, perform natin. So, that's 0. This is 1. 1 and then 1. And then, this will be the answer. So, anong napansin nyo? Iba yung kanyang answer. No? May additional 1 dito. Ito siya. Wala. So, parang parang behind siya ng 1. Okay? So, tignan natin saan magkatugma yung truth complement. Sa radix minus 1 ba or sa direct method? Try natin, no? So, yan. So, try natin. So, ang gagawin muna natin, perform na tayo ng 1's complement. Add tayo ng 1. After that, add na natin, no? So, ito na yung 2's complement equivalent natin. So, ito ngayon siya, i-add natin sa ating minuend. So, mangyayari, this is 1, 1, then 1, then 1. And this is already our answer. So, anong napansin nyo? This is similar to the result of the direct method. Kaya yung direct method or yung answer ng ating calculator are always in truth complement. Yan yung tatandaan natin. Yan. So, ito na naman yung sa direct method ng what if kung if ito yung yung equivalent. So, kailangan na natin i-convert itong ating given into binary numbers. So, ito naka-binary na siya. So, once na naka-binary na siya, that's the time na mag-perform ng subtraction. So, yun yung gagawin natin, similar with the direct method. Now, dito sa pangatlong example, so we have here two numbers with different number system. Ang isa is naka-octal, ang isa is naka-hexa. So, first, gagawin natin dyan by direct method. So, kailangan muna nating i-convert, ang dalawang number na ito into binary. So, ito na yung binary equivalent niya. So, once na na-convert natin sila, at saka, importante din na dapat ma-align natin sila with in reference doon sa decimal point natin. So, ito na yung nagiging arrangement nila. And then, yung mangyayari na lang, 'di ba, susundin lang natin yung nasa table. So, ito siya is magiging since ito agad 0 ang kanyang minuend. So, kailangan natin magbaro sa kabila. So, ito siya ay magiging 0 din, no? So, yan, magiging 0 na. So, nagbaro siya ng 1. So, yan, nagiging 1-0 na. And then, once naging 1-0 na, minus natin sa 1. So, meron na tayong result na 1. And then, ito, since this is 0, so, magbabaro tayo sa may kalapit lang na mayroon tayong mapagkunan. So, ito siya is magiging 0. At ito siya is magiging 1-0. So, ito siya is nanghiram na naman tayo. Magiging 1 na ito. Ito siya is magiging 1-0. Manghihiram na naman tayo dito. At ito siya is magiging 1-0. So, 1-0 minus 1, yan na yung 1. So, ito siya is magiging 0. Ito naging maging 0. And then, ito since 0 minus 1 na naman ito, manghihiram na naman tayo. So, this is 1-0. And so, 1-0 na ito. So, 1-0 minus 1. So, yan na yung meron tayong 1. So, ito magiging 0. Ito magiging 0. Ito magiging 1. At dot. 0, 1, 0, 1. So, manghiram. Sa kabila. Yan, magiging 1-0. So, yan. So, yan na naman tayo. So, this is will be equivalent to 1. To 0. Equivalent to 1. And then equivalent to 0. So, yan. Yan na yung ating equivalent sa direct method. So, after that, hindi natin kakalimutan na kailangan natin i-convert din ito balik into octal and hexa. So, ganun. Next is by radix minus 1 method. So, yung gagawin natin pa rin, we were going to convert each of this number into their corresponding binary equivalent. And then, itong nasa subtrahend natin, since radix minus 1, kailangan lang natin i-invert. So, yung inversion niya is ganito na. So, mangyayari ngayon, itong na-invert natin na number is i-add na natin dito sa minuend. So, ito na yung mangyayari, no? Yan. So, once na nakaset up na siya, pwede na nating pwede na tayong mag-add, no? So ito, kasi ito 0, so dito na tayo magsimula, no? So, this is equivalent to 0, and this is equivalent to 1, 0, 0, 1, so 0, carry 1, 0, tapos carry 1, tapos this is equivalent to 3, so this is 1, then that, carry 1, so 0, and this is 3, carry 1, so this is 0, then carry 1, this is 1, this is 1 dyan, then it is 1, 0, tapos this is 1, and this is 1. So, since overflow bit natin, since meron tayong overflow bit, and yung basis pala ng ating overflow bit is yung sino yung pinaka mababang digit sa kanilang dalawa, and that is itong second natin, give us second number natin. So, yung mangyayari, itong overflow bit is i-add natin sa pinaka-last. So, magkakaroon siya ng, so mag-a-add siya. So, ito na yung magiging result. Ganon. So, yan. Now, how about sa truth complement? So, yung mangyayari, convert pa rin natin ito, and then co-convert natin yung ating subtrahend to one's complement by inverting. And once we inverted it, since we will be using truth complement, i-add natin ng 1 sa least significant bit. So, magkakaroon tayo ng ganitong equivalent. Now, this converted truth complement will be added here sa ating minuend. So, so ito na yung ating nakuha kanina, and then ito na yung minuend natin. Now, gagawin natin, i-add na lang. So, this is 1, 1, 0, 0, 1, 0, 1, 0, then 0, 1. Then, this is 1, this is 1, 0, 1, 1 na naman ang carry. So, this is 0, 1, 1, 1, 1, 1, 0, 1. Then, ito, meron tayo. As you would try to compare it to our number here that has konti, no? Smaller digits, no? So, smaller number of digits. So, we have here an overflow bit. Yung gagawin basta overflow bit under two's complement is mawawala, maka-cancel siya. So, ito na yung magiging answer natin. So, still, the equivalent is 272.446 NBA.93. Ganun lang. Okay. Yan, nahuli pa yung. So, now is yung multiplication. So, sa multiplication, this is similar lang sa paano tayo nagmo-multiply sa decimal multiplication. But simpler than that. In binary system, each partial product is either 0, multiplication by 0, or exactly the same as the multiplicand or multiplication by 1. Actually, in digital circuit, multiplication operation is done by repeated addition all partial products to obtain the full product. So, for example, meron tayong itong example na ito. For example, ito. So, yung mangyayari is that ito siya, multiply natin dito sa itong number na ito. And then, sunod na naman ito, multiply pa rin natin sa ganitong number na ito. And then, ito din siya, i-multiply natin dito. And then, dito siya, i-multiply na naman. And then, ito, magpapass through ng 0, 1, ito naman yung result. So, parang ganito na siya. So, this is first, no? Then second, no? move lang natin ng isang space kasi wala pang 0. Next, kasi ito na siya, so nag-move pa rin tayo ng space. And then sunod is ito, kasi nag-move na naman tayo ng space. Ito na siya. Pag nagdaan na tayo sa 0, magsispace tayo ng dalawa. Yan. So may isa at meron tayong dalawa. Kasi nga, bakit dalawa? Kasi 0 times this number is still 0. So yan. Then may dalawa pang igayahin natin. Okay, yan. Isa na lang pala. Okay. So ito na yung setup natin. So once na may ganito na tayong setup, yung next na gagawin na lang is i-add na natin sila. Very simple lang and very straightforward lang ang pag-add natin nila. So erase ko muna itong para hindi masyadong magulo. So okay. So yung una, ito lang ating isipin. Ito yan. Tayo malibat. So yung gagawin, add natin, this is equivalent to obviously 1, this is equivalent to 2. So 2 is 0, carry tayo ng isa, so magiging na ito 3. So 1, copy na naman tayo dito. 1, 2, 3, 4. So 4 is 1, 0, 0. So yung ating labas dito is 0. Pero ang remainder niya dito is 1, 0. 1, 2, 3, 4, 5. So 5 is 101, right? So this is equivalent to 1. So this one na natin, no? So 2, 3, 4, 5. So 5 is 101. So 1, 0 na po dire. 1, 2, 3, 4, 5. Okay, so 5 man na siya. So 1, 0 na po dire. So 2, 3, 4, 5, 6. So 6 is 1, 1, 0. So may tabo dire is 0, 0, tapos ito is 1, 1, 3, 4, 5, 6. So 0, 1, 1, 3, 3, 4, 5, 6. Okay, so si dito naman is 3, 4, 5, 6. So 6, 0. Yeah. 2, 3, 4, 5, 6. So 6. And then ito ay 1, 2, 3, 4, 5, 6, 7. So 7 is 1, 1, 1, 2, 3, 4, 5. So 5, 0, 1, 0, 2, 3, 4. So 0, 1, 0. So then 1, 0, 2, 3, 4, 5. So 0, 1, 0. 1 din eh. So this is 2, 3. This is 0, then 0, 1. Okay? Ano lang kasimple ang ato ang kuan. So ganun lang yung process. Pero delete muna natin ito sila. So, kung ano natin, i-animate. So, this is equal to 1, 0. Yan. Ano yung ginawa natin. Yan. So, ang tanong, saan natin ilalagay ang decimal point? So, bilangan lang natin ito. So, 1, 2, 3, 4, 5, 6, 7, 8. So, galing dito, 1, 2, 3, 4, 5, 6, 7, 8. So, dito na yung decimal point natin. Yan. Yan yung answer natin. Yan. So, tapos na tayo sa multiplication. Next is division. So, remember this table. 0 divided by 0 is not allowed. Basta ang divisor is 0 is not allowed. Anything else, pag 0 si dividend, that's 0. If dividend is 1, and then divided by 1, that's 1. Ganun lang. Very simple. So, yung mangyayari pag ganito yung example natin. So, yung ating decimal point, so, kailangan ito siya, magiging whole number dapat ito siya. So, para maging whole number, lipat natin yung mag-move tayo ng dalawang digit papunta sa right. So, ito din yung gagawin natin dito sa pagde-divide natin. So, yung una nating gagawin, pwede natin gumamit ng calculator. So, 1101.001 divide natin sa 101. Nangyayari, so ganito na, no? So ito siya i-divide natin, no? So magkakaroon tayo ng 101. Ito namang 101 i-multiply natin dito sa ating sa ating divisor, no? I think that's divisor. Yes. So divisor, no? Pag once makuha natin ang divisor natin, so meron tayong answer na ito, no? So once na minus natin ito, we have come up with 1, 0. So magbaba tayo ng 0 dito. Pag divide natin, that's equivalent to 0. Pero 0, multiply mo na naman agad dito. So magkakaroon tayo ng 0. Tapos meron tayong 100. Then bring down na naman isang 0. So ito na naman siya, i-multiply natin dito, no? Multiply natin. So magkakaroon tayo ng 0 pa rin. 0 kasi pag multiply natin dito, sorry, dahil kanina is divide pala yun, no? Hindi multiply. Yan, so ito kuha na po nato siya. So kaya mo na siyang 100. So plus pag yun din isa. So kuminan ako diligapon so nagbutong at tagkuan. So kani siya divide na to ani. So still it's 0. So 1, 0 na siya. So add na pagta isa. So medyo muwan na ni siya. So 1 times kanin 1 times, no, times itong buhaton. So this will be equivalent to 1001. So once na magkaroon tayo ng 1001, so ano naman, add naman tayo. So ito siya, i-kuha natin, i-divide natin siya. So once ma-divide natin siya, so magkaroon tayo ng 1 na naman, and so on and so forth. So ito na yung kanyang remainder at last. So once na meron na tayong remainder, so ito na yung answer natin, tsaka ito rin yung remainder natin. Ganun lang, no? Very simple. Now let's proceed to the sign binary numbers. So in digital circuit, there is no provision to put a plus or minus sign, since everything in digital circuits have to be represented in terms of 0 and 1. Normally, an additional bit is used as a sign bit na tinatawag natin. And the sign bit is always placed at the most significant bit. For example, if you are implying that this number is negative, you just put 1. If not, that's equivalent to 0. Yan. So, let's take some example about sign binary. For example, ito 19. Ang 19, may equivalent siyang binary na 10011. So, So, yung mangyayari pag once ko complement, so pwede tayong first isa sign magnitude natin. So, kung sign magnitude, so ilagay lang natin yung 1 kasi negative 19 yan eh. So, ano pala ang representation ng negative? That's equivalent to 1. Kaya, lagyan natin ng sign magnitude. Ang iba, nilalagyan nila ng maraming 1 just to signify that this is purely negative number. So, kung once complement naman, itong ating na-solve, itong nakuha natin na conversion from 19, i-invert lang natin. Yan na yung negative, yung sign binary niya. So, pag ano naman, pag iba na naman ang pag 2's complement, no? Gagawin, dadaan pa tayo ng proseso, pero mag-add tayo ng plus 1 sa least significant digit. So, 1, 0, 1, 1. Ito yung answer natin. Okay. Ganda, no? Next is code. So, when we are dealing with code, we have two kinds of code. Ang first one is the weighted code, and the second one is unweighted. Pag sabi nating weighted code, these are the numbers that are very dependent based on the weight of their position or their digit. So, for example, meron tayong mga number na BCD. May corresponding weight yun siya. Basta pag nabilong ka sa A, B, at saka C. Tapos, meron dito yung 8421 code. Maya, meron tayong example niyan. Unweighted code, these are, weight is not assigned, no? For example, excess 3. Yan naman, kaya mag-add man kang 3, no? Gray code, napon siya lain yung mekanismo. So, this is, tawag itong unweighted codes. Okay. For example, so ito yung mga, comparison of every, form, no? Meron tayong decimal digit, ito yung equivalent sa BCD niya or binary coded decimal. Problema lang sa binary coded decimal, for example, magtuntong siya ng 2 digit, dalawa din yung dapat i-convert into 4 digits. Then we have also excess 3. Ang napansin nyo, every time na mag-decimal natin is 2, 3, 4, 5, nag-a-add siya ng 3 linya. Okay, yan yung ating tatandaan, no? Then meron din tayong 2, 4, 2, 1. So, pag upuan mo ito, marami kayong mag-discover na kapare-pareha lang pala sila. Meron din tayong gray code, no? Mamaya meron tayong demonstration paano siya code. So, yan. So, BCD are state assignment of the binary number. Excess 3 is unweighted, obtained from the BCD after addition of 3. Then 8421 negative weighted code, and then 2421 and 543210 is actually a weighted code. So for example, no, let's go in depth with gray code. So any binary number can be converted into equivalent gray code by the following step. The MSB of the gray by the gray code is the same as the MBSB of the binary number. The second bit next to MSB and the gray code equals the XOR and MSB, and second bit of the binary number, it will be 0 if there are same binary bits, or it will be 1 or a different binary. So ano siya. So na ko yung example din sa convert to gray code pinagitan kaning sa gray code ato lang unaon ng XOR gate nga naman tanawa itong buhaton kanin siya bring down nato 1, then 1 XOR 0 is equivalent to 1. So mura gyapon ka nag-add, pero problema lang ani inig-abot nimo sa 1 and 1, so 0 siya. Okay, so ito siya 1 og 0, this is 1 og 1 na imong 0 0 imong 0 kani na imong 1 then kani na imong 0. So mo ni siya ang iyang gray code equivalent. Okay, napon tay floating point. So kung tanawon nimo kung ang number, this is in binary, kung exponent siya, kung yung calculator nyo lang actually type sa calculator nimo, dapat ang mode sa inyong calculator is math lang. No need to work with other computerization, no, during the subject. So yung exponential form ganito, try nyo sa inyong calculator. Then yung 1 to 7 normal, yung that's equivalent to 127 plus 11. So that's equivalent to 9, 131, 139. So, pag ganun, yun yung equivalent natin dito. So, 139 is equivalent to 100, 1010. Ang mantisa is actually derived from the equation, no? Kanina itong equation. Pero dapat na lungagan mo siya 0 sa least significant bit para masigo ang 21 bit. And the same also with this, no? Kanina lang siya negative, pero it was able to escape also. O, tanawa lang ang pattern. Kanina siya negative 8, so 1 to 7 minus 8. So, that's equivalent to 99, no? And so, ito rin yung equivalent number niya. And this is the mantisa. And I think that's all, no, for our logic circuits, for switching circuit. Next meeting, we will go to discuss combinational logic circuit. So, we're ready for our class for that.